So next up, we have Paolo Bolletta from GARR, and Paolo will give us an update about the GARR network, and he will, one second. So he will tell us about, so last year we had Massimo Carboni telling us about alien wavelengths, and this year Paolo will tell us essentially about the impact of SDN and APIs and the DevOps on optical networking.
Okay, good morning, everyone. I'm Paolo Bolletta, an optical network engineer in GARR. It is the Research and Education Network in Italy. Today I'm going to talk about open optical networking and disaggregation in optical network. Here, the outline of the presentation. First of all, I'm going to recall on GARR activities and giving some update on our network evolution. After that, the main topic, the disaggregation in optical network and open light systems. After that, I'm going to try to address opportunities and challenges in this approach and give some use cases on it. Finally, some conclusion, but mainly some open points and points to discuss together. GARR is the Italian Research and Education Network. First of all, it's a community of all the universities, research and education institute in Italy. We operate a national-wide network providing high bandwidth transparent connectivity, advanced IT services, and support for infrastructure for the research and education community. This is briefly our network footprint, focused mainly on the optical and transport infrastructure. That is the focus of this presentation. Basically, we directly operate more than 9,000 kilometers of backbone of fiber and more than 6,000 kilometers of access link. We interconnect more than 1,000 user sites and operating more than 1 terabit of access capacity and 2 terabit of backbone capacity. Here there is the footprint of our transport network that is based on DWDM, OTN, and RDM nodes. We used to operate 2 separated optical networks, one in the center and the north of Italy, and another one in the south. The first one was rolled out in 2011, based on one-way platform on DCM compensated optical infrastructure, can provide 1G and 10G services. The other one that was deployed in the south of Italy in 2015, based on the Infinera platform and coherent transmission. We can provide on top of it 10G, 40G, and 100G services. After that, we roll out just these years what we have announced also here last year. Massimo Carboni presented this approach of alien waves integration between the 2 separated optical infrastructure. We have rolled out this solution interconnecting with 100G services, our main POPs in the center and north of Italy. Our service layer is based on IMP-MPLS network, based on Juniper MX platform. Our metro aggregation and CPE element are based on Cisco platform. Getting back on the alien wave integration, this is the press release a few days ago published, where we announced that we have finished the integration within this technique of the 2 different optical networks. We provide with this solution 100 gig services over more or less 3,000 kilometers of fiber. We interconnect our main POPs in Milan, in Bologna, in Rome, and in Bari with this solution. In this way, we achieve an evolution of our services, and also it was an effective way to roll out this capacity in a very small amount of time. At European scale, our research and education network is connected with the other countries, with the other research and education network, with a GANT network that mainly is our principal upstream provider for research traffic. Within this context, we are involved in a lot of activities and European projects. In particular, I want to mention this one that is about the evolution of a shared optical infrastructure. Within this project, we are evaluating the usage of cross-border fibers and alien wave integration on top of the national-wide optical network in order to offload the GANT network dedicated infrastructure in order to complement it as well. In this context, we are also discussing some technological and operational issues about the deployment of alien waves and of direct interconnection at optical domain between different networks and administrative domains. Let's get on the main topic. What is the main result that we achieve with the alien waves? First of all, we had the opportunity to decouple the transport layer from the photonic layer. This is the key point. Usually, DWDM or transport network are provided as a monolithic solution, a unique solution, integrated and engineered by one vendor. You have to evolve with the vendor if you want to get evolution on your services. With alien waves, we decouple this aspect. We can speed up the evolution of our transport layer, growing in capacity, without touching all the elements that compose the photonic layer. That is the more complex and more geographically spread all over the country. This slide wants to underline that within the same solution, within the same transport solution, all the elements that compose this monolithic solution can have different lifespan of these elements. For instance, on the transport layer, transponders needs usually to be updated and renewed within a 3-4 years time frame. The photonic layer, DMAX amplifiers, and so on, have a lifespan of 8 to 10 years. Obviously, the fiber layer is the more stable and can run up to 15 and 20 years. So we can, in this way, with alien waves, renew just the transport layer where our service are. This is one of the main advantages. This is a really novel approach that overcome the alien wave approach, and we can get from an integrated model to a disaggregated model. Basically, what the vendors and transport network are composed by monolithic optical network element, where all the functions that compose the solution are integrated in the same box or in the same solution. It's really difficult to put somewhere else some element in this kind of environment. In this way, the main critical issue is that you have, if you have different solution and vendors in your network, you cannot run services from one top to another end of your networks just because there isn't a real integration at the optical layer. So it's really tricky to integrate this solution. Alien wave can be a way. Recently, the technological trend is to disaggregate this solution, putting all the elements that compose this closed environment, spreading it in different elements, different boxes that can be engineered together, putting in the network element just the functions that you really need and just where you really need. Also mixing and matching different solutions from different vendors. This is one of the key points. In this way, you are forced to define some common interfaces also at the payload level, at the data link level, and you can integrate naturally your optical layer. In this way, you can run one service from one end to another without leave the optical layer. This can be a really important advantage in optical networking. Here's some comparison of these two different approaches. Aggregated network are usually engineered and optimized by a single vendor. You can buy a turnkey solution because the vendor integrated it for you. You can refer just to one focal point. You have just one focal point to complain with for assurance and so on, maintenance and so on. All the tools, side tools in optical networking, for example, design tools, validation tools, and troubleshooting tools are integrated and lives coupled with your solutions or are optimized. You can also benefit from the cost point of view of a large-scale environment. In disaggregated network, you can achieve a really fine and better customization of the network element. So you can put just the function that you really need in your network and not pay for anything else that you really don't need. You can speed up the innovation life cycle because you can update and renew just the element that is an added value for your services. You can decouple services from infrastructure. This is a key point. So if you consider the sustainability of this model, you can put all the elements that has not a key role in your services in the infrastructure, also amplifiers and so on and so on. A smooth evolution is really more simple in this way. You can light up just the service that you need for the time that you need if you want to move your traffic from one point to another. And you can also avoid functional replication that is common in a layered network. Maybe you have more than one layer that do the same stuff for you, and you pay twice for the same service. Here's some definition that we point out at European level. This is the disaggregation in the optical data plane. The trend is to move from an aggregated model where all the transport network is integrated by one vendor and where the demarcation points are outside your optical network, from a partially disaggregated solution, also known as open line system, where all the photonic layer is engineered by one vendor or one entities, and where you can put all the services on top of it in a disaggregated way, decoupling the services from the infrastructure. In this way, you have more than one demarcation point, and you have to address and manage this element. The ending point is a fully disaggregated model where all the elements can be provided as a standalone solution. We have to integrate it with all the span and pieces of your network. Even the same network element can be realized with different boxes of different vendors that perform the better function that you need from the technical solution that you assess as the best you want. In this way, you have a lot of demarcation points. You have to deal with a lot of complexity. Obviously, there is a strong change in how the control management plane is developed. Usually, there is a unique control plane in transport network. If you deal with a fully disaggregated model. We have a lot of boxes from different vendors that performs in different way. You have to integrate it and also to control it with a distributed control plane that is not common in optical and transport domain. Obviously, it's easy to understand that APIs and Norbar interface has a key role. And you have to orchestrate all this solution in from a focus point, basically. Obviously, if the disaggregation breaks through the closing of this solution, you have to manage this environment with APIs and northbound interface. You have to manage all these different kind of boxes. So it's mandatory a really strong integration effort. You have to deal with a multi-vendor solution. There are a lot of standardization effort in this area, a lot of different initiatives from that mainly are not fully overlapped. There are a lot of different approaches. These are the main three approaches. You can speak directly with the network element. You can speak directly with the API of the at network-wide level, or instead you can have an abstraction layer that decouples these kind of things with a northbound and southbound interface. We had a lot of opportunities in this approach. We can break through and resolve the vendor lock-in. We can have a mix and match approach that we used to in the IP and MPLS layer. Decoupling the photonic and transport layer, we can have a lot of benefits. We can have a lot of opportunities also because we can think about the direct interconnection at the optical layer between different domain network. There are obviously a lot of challenges. The extreme modularity can be an issue, can be a big deal. There is a lot of management control plane integration that needs to be addressed. We need to deploy planning tools and design tools in order to address the analogic world that deals with the optical network. Obviously, the operational troubleshooting model is not trivial because you have to understand which is the entities that you have to complain with in case of troubles. And the software become more and more critical in this solution. This is some use cases just as discussion starting point. You can, for instance, imagine that you have a common infrastructure shared between different entities, different users, different service providers. This shares not only the fiber, but even shares the photonic layer. With a hierarchical model in controlling this system, you can imagine that you can virtualize your optical network as your own network on top of a shared infrastructure. You can also imagine that this infrastructure can be shared between different services, metro, long haul, or on data center interconnection services. Another important use case in our perspective is the direct interconnection between different domains at optical level. Instead of interconnecting by IP routers or MPLS-based VPNs, we can imagine to put a photonic layer in the demarcation point between different countries or administrative domains or operator network, and put on top of it the services at the lower layer that you can, so at the transport layer. This can be a really opportunity to offload the IP MPLS layer. Some conclusion. In GARR perspective, upline system are the natural evolution of the optical network as a next step moving from the alien wave. The coupled services from photonic layer is really an opportunity for us. We can have a flexible behavior and solution with mix and match approach also at the optical transport network. This is a key point. We can move this flexibility from IP MPLS layer through the transport optical layer. We have to enable automation and programmabilities on this usually static layer. We can achieve a smooth evolution path. And Obviously, we have to remark that a fully disaggregated model seems to be not sustainable in our perspective because we have to address a lot of stuff, a lot of integration, a lot of issues in also in operational models. Obviously, the effectiveness of this approach depends on this diffusion. If we are alone to embrace this approach, there is no benefit. So we have to spread this point of view. I also, just the last slide, we are facing in GARR these issues as an internal process to address the infrastructure evolution of our network and also the evolution of software services on top of it. We start an internal project that called ELISA that wants to address and technologically scout all the possible solution. We point out these views and this approach and also our customer requirements in a white paper. There is the URL, you can download it and comment it. And I want just to thank GARR, the ELISA project, and the project in that European level that we are involved with. And that's all for me. I don't know if there is a comment or question.
Thanks very much. Paolo?
Maybe I'm on time.
Any questions for Paolo? No? Thanks very much.